much. I'm very happy to be here. I've been giving talks virtually for the past several years, and that's pretty yucky, actually, because you can't interact and you can't see people, and I sort of feel like I'm, talking to my cats.
We need to get your video working.
Okay.
There we are.
There we are. All right. Okay, good. So as Bob said, I'm going to be talking today about this evaluation conference at NIST, which is called TREC. But before I started that, I thought I would give you a little bit. No, it's not going to do that. Okay, how about this? No, it's not going to do that either. There we go. Click with more options. So a little bit of information about NIST. One of you at least doesn't need this, but so NIST is the National Institute of Standards and Technology. It's in Gaithersburg, Maryland, and Boulder, Colorado. And its mission is to support U.S. industry through standards and measurement. And measurement is really, really important to NIST, right? It's really important to NIST. And largely because of this idea that the belief that if you can't measure it, you aren't going to be able to improve it. Okay, so measurement is a core piece of NIST, such that they created a set of trading cards with the 7 international units and their chief nemesis, major uncertainty. Okay, so these are actually on the NIST website somewhere. And you can print your own. There's also, I'm a couple days late, but they also have Valentines with featuring the 7 international units. The 7 international units are basically physical properties, right? And NIST does do a lot of measurement of physical properties, but that's not all that they do. As far back as the late 50s, NIST had some work going on in language processing, and in particular, the late 50s was work on what would now be considered machine translation. And you probably have heard the story about the machine translation at the time. It was between English and Russian, and they gave it the spirit is willing, but the flesh is weak. And it translated to it, the meat was so-so. Oh no, I got that wrong. The vodka was good, but the meat was so-so. Now that's probably apocryphal. That probably didn't happen, but in the NIST archives, there really is, from the work at the time, you'll see there it says water goats, right? This was a more recent story, a 2016 story taken from the archives about Ida Rhodes and her water goats. And she went and explored why it is that all these papers were coming out with water goats. What's a water goat? Any ideas? Hydraulic rams. Okay. And also, here's a record in 1963 of what would be considered an information retrieval conference. Okay, so this is the report was issued in '63, so the work was going on before then. All which is just to say, NIST has a history also of language processing, and that has continued. Fast forward a couple decades, and early 1990s, DARPA came to NIST with this request to help be the evaluator for a program that DARPA was starting up called TIPSTR. TIPSTR was looking at being able to process natural language, mostly English at the time, in order to be able to do entity extraction, but also information retrieval. The part of the information retrieval part was to evaluate a set of systems that were the performers for DARPA on this TIPSTR contract. And NIST, who was basically Donna Harmon at the time, came back and said, well, no, we can't really do that. And I'll get into why not. But what we can do is we can create a conference, we invite lots of people and build you a collection through that way. And that was the beginning of TREC. This was in 1992, right? So keep that in mind. 1992 was a long time ago now, right? It's 30 plus years ago. It was before there were internet search engines, okay? The amount of memory one could buy for, say, $10,000 was actually not all that much. DARPA gave grants to TREC participants in order just to hold the data, because the universities, et cetera, who were participating at the time couldn't afford the storage to hold the data, right? So keep that in mind as we go through here. This was early. Since that time, we built a whole bunch of different test collections, and I'll get into what a test collection is more later. There's been hundreds of participating teams worldwide, and it's become the venue for where we really decide methodological issues about how to do research and information retrieval. So why am I calling this thing a coopetition? Wikipedia defines a coopetition as being competitors cooperating, right? I prefer cooperative competition, you know, to sort of put the emphasis on the cooperation, at least for TREC. IR actually has a bunch of these things, and actually it has grown now to be not just IR, but all sorts of different fields now have these challenge problems, or community evaluations, whatever you want to call them. The idea is you've got different competitors agreeing to participate in order to build a common resource for the common good. And the idea why these are good is that while the competition, you're competing, if you win the competition, you might get a bigger piece of the pie. But if you're cooperating, the whole pie gets bigger, right? And that's what we're trying to focus on. So let me go, I actually didn't say this. If people have questions or anything, feel free. Yeah, go ahead.
What's the overall long-term objective of this cooperation?
To build better retrieval systems, search engines, to build better search engines. So TREC did not start in a vacuum, right? I talked about how NIST had a history in this. The field also had a history from about the same time, right? Mid-60s. There was a person by the name of Cyril Cleverton. He was a librarian at the Cranfield Aeronautics College in the UK. And he decided that he wanted to compare indexing languages. So an indexing language is just what it sounds like, back of the book index. How people used to use library cards. They put these index terms on the library cards. Well, that's what he wanted to compare. In mid-60s, there were all these different schemes for ways that people thought would be the best way of indexing content. And Cyril Cleverton wanted to test these different methods. And the way he came up to do that was to build what became known as a test collection, right? So he got a set of documents. Since he was at the Cranfield Aeronautical College, these documents were journal articles on aerodynamics. And he got a bunch of queries or questions or requests, whatever you want to call them. Actually, I'll call them topics because that's what they're called in TREC. So the topics is sort of this natural language statement of information need, right? And where he got his, he called the requests, where he got his requests were from users of the library. And so they were germane to the set of documents that there were. And then he also had these things he called relevance judgments, which are basically the right answers, right? It says for this request, this is the set of documents that should have come back, okay? And with that information, he compared these different indexing languages, and his conclusion at the time was that the best way to index these journal articles was through the words that were in them. Just straight use the words that are there. This was heretical at the time. He was absolutely vilified in the literature for making this conclusion. Now it's pretty much accepted, and the Cranfield tests are better known for this idea of a test collection. So what this test collection is trying to get at is defining what makes a good search result. right? So what does it mean to be good? And therefore, what does it mean to be better, right? You can't really define better if you don't know what good is to begin with. So here I have an example on the left. This is actually old at this point, but it is. So I put in TREC, TREC, into a search engine. I think this one was Google, but I won't swear to that. It might have been Bing. And I, of course, as the program manager of the time of TREC, wanted the text retrieval conference to come out first, right? But in fact, what came out first at the time was the Texas Real Estate Commission, which was a perfectly fine answer. Probably if you went by frequency of people looking for the word TREC, the Texas Real Estate Commission would probably be more popular of an answer rather than the text retrieval conference. Notice the text retrieval conference came in second before the Tennessee Real Estate Commission. Okay, so Tennessee with less real estate interest than Texas, apparently, at least according to this. Right, but the point here is that search is inherently a user activity, right? These users are searching not because they want to search, right? But they're searching because they want to do something else. They want to find information to do something else. Maybe that is just to be entertained, but there's, it's inherently a user activity. Different users are going to have different ideas about what's right. And those at times are going to be conflicting ideas about what's right. All of which is to say there is no single truth. Okay, different people are going to want different things. If we're going to try and to evaluate what a good search result is, we're going to have to put a stake in the ground somewhere. And so part of this is how do you get around that? Because it's a fact of life that there is this level of uncertainty. So the Cranfield paradigm sort of abstracts away from all that messiness of the user, right? And says, okay, we're going to just ignore all this messiness. And what we're going to say is you've got a set of documents, you've got a set of requests. The systems are going to return a ranked list of documents. And that ranked list should have relevant documents ranked in front of non-relevant documents, right? That's the sole criterion, is going to be rank relevant documents before non-relevant documents. If you do that, you see that green line that goes straight up, that would be the ideal retrieval, because the x-axis here is the number of documents the system has returned. The y-axis is the number of relevant documents it has returned. Perfect retrieval follows that straight line of the green line. Normal retrieval, or actual retrieval, is likely to be closer to the red line, which sort of meanders up there because some non-relevant gets mixed in. So any reasonable measure of system performance is going to be based on the distance between that red line and that green line. Okay. Now there's a whole slew of different measures, because different measures focus on different parts of this, right? So sometimes you might care, and in fact, usually you care more about low levels, the number of documents that have been retrieved, right? Because especially if you think of something like web search, nobody's really going to want to see every document out there that is, relevant. You're going to want to focus on the end. But there's a wide variety of measures for a wide variety of different ways you might want to interpret the task. Cranfield says nothing at all about any of that, just rank relevant documents before non-relevant documents. Complicating matters even further, however, especially for me as a measurer of system performance, is that different systems, the variance between the results that you get from different systems is almost always smaller than the variance that you get between asking different questions, right? So what this graph here is showing, the heavy red line is the average performance, and that's what usually gets reported in papers and things. These other lines are the individual topics results that have factored into that average. You can see that there is just all over the place, right? Which gets smooshed into that nice clean little red line that goes down. And if your signal that you're trying to measure is smaller than the variance of what question is being asked, right, that makes it much harder to measure. And so there's that problem also. It is because of this variability that Cranfield, the paradigm has evolved such that you almost always report results as averages over a bunch of topics, because any one individual topic is going to be not particularly representative of much, right? Okay. So just to recap here, Cranfield has defined what Karen Spark-Jones called the core competency of search, which is just rank relevant before non-relevant. Different effectiveness measures actually represent different tasks, right? So because if you are a lawyer wanting to find any precedent that's out there, that's different than a web search, and where you're trying to find a one answer to a document that contains the answer. The abstracted tasks that these measures represent are treated, at least, as being necessary, right? A good retrieval system has to be able to do that, but is not sufficient. An actual in practice use retrieval system is going to have to do a lot more. It's going to have to decide how it's going to present these things. It's going to have to try and eliminate some of the duplication that's in there. I mean, there's going to be all sorts of different things that the real retrieval system will have to do. But Cranfield ignores all of that. And in order for this test to actually be a good tool, these test collections to be a good tool, it should be the case that your documents and your requests or your topics are actually representative of where you're going to deploy your system, right? It makes no sense for you to train your system on the Wall Street Journal, which is where a lot of the TREC collections of data has come from, and then try and retrieve medical documents, right? That's not really very effective. Okay, why do we want to do this? Right, we're throwing out so much information, it doesn't really work. Well, Cranfield has been shown to have sufficient fidelity to the real user task to be useful. It is general enough, though, to be broadly applicable, relatively inexpensive, feasible to implement. But you do lose realism because you've not done this abstraction. You do lose some realism, but that loss of realism has given you control over enough variables that you can get more power out of your experiments. Okay. All right. So that's sort of the background of why were we doing this at all, right? So we're trying to build this infrastructure for other people, researchers in information retrieval, to have this tool that they can use to evaluate how well their systems work. Okay. This infrastructure actually includes more than just the test collection, although the test collections tend to be the biggest part of it. But it's also sort of the task definition at all. And that involved in that task definition is the measures that are used. But also the methodology of what is the right way of going about implementing the specific pieces of this for the task of interest. Here's a high-level overview, sort of the way that these things, and particularly TREC, is run. The organizers of the thing provides the documents and the topics. They get sent out to participants. Participants are whoever wants to do so, including mostly university research groups, but also companies and government labs. And I mean, so it's sort of a wide spectrum of interested people. Most of it is research systems, though. Some of those results get annotated by humans. Okay, so that's a big piece here. We have humans looking at some subset of these documents in order to say what should be retrieved or not. And because they're being looked at by humans, you can only do so much. And right, that becomes the sticking point. How do we get enough judgments to be able to evaluate systems on very large corpora when you have humans in the loop who need to, so we have to be careful here of what we're assuming we're going to have as our relevance judgments. Once you have those relevance judgments, you score the systems, and then all of the data and the annotations and everything else get sent back out to the participants. And in the case of TREC, they eventually go out to the TREC website. And so anybody can see, we make everything public after the fact. So all the actual results that have come in are public, along with the collections. The test collections are obtainable from the NIST website. All right, so what are the benefits here of holding these sorts of coopetitions? This will apply particularly to information retrieval, but I'll also claim that it's more general than that, than just information retrieval. It is generalizable to at least other language events, and probably also, frankly, in my opinion at least, to many others places where they're currently using leaderboards or other, using test sets in order to drive the research. So here are the 5 main points that I see as the benefits, and I'm not going to stay on this slide because I'm going to go through each of these in the upcoming slides. There are some downsides, and we'll talk about those too. So the first thing is that these coopetitions do improve the state of the art. Right? We can demonstrate this. So over the 30 years now of TREC, we can demonstrate this in a variety of different ways. The main way that this slide is showing, in the first 8 years of TREC, the score that was being used, which is called mean average precision, you don't have to remember, care about what mean average precision actually means. But essentially, the mean average precision doubled in the first 8 years of TREC for the TREC participants. Okay. The main reason of why that improvement happened was because the individual research teams could get these test collections and essentially do human involved hill climbing over this collection and lots of different tests all on their own very quick cycle, because they had this test collection which could tell them what was going on, and that definitely did drive improvement in the research. It also, though, speaks to the first risk, which is, unless you're careful, you as the evaluator, you as the community, somebody in there, you have the real danger of an entire community overfitting to a single test set. Right? And the only real way that I know of, at least of preventing that, is not to have a single test collection. You have to have multiple of these things, because you are going to get the entire community overfitting. Yeah. Well, the way you recognize it is the way that you would recognize any overfitting, which is you take the retrieval system of not on that particular test collection in some other one, and it fails miserably. Do I have a good example? We've been trying to be careful not to do that. So there is an example. There's a data set out there for categorization, automatic categorization. It was based on an old Usenet data set. So you remember Usenet? And they had categories. And so this data set is, I don't remember how many, but say 25 different of these Usenet categories. And the idea is to plop the Usenet articles by category. And if you looked at the best performing systems of, at least early on in the use of that data set, you'll notice, people noticed that the most salient things that the systems were picking up was the path in the Usenet hops of where it came from and where it was going to. That's not something which you really want to pick up if you're claiming that you're generalizing over over text to be able to categorize. It's those sorts of things.
You have the same kind of things coming up an evaluation of image classification, and it's focusing in on the copyright notice as a thing that was in my own work. When things started with Tipster, there was the information retrieval community and information extraction. The information extraction community was pulling, classifying pieces of things like named entities. This is a person, this is a location, this is an organization, and trying to make connections between these things. And they had the computational linguistics community had these shared competitions. And I evaluated this stuff, and I said, here's two completely different systems evaluated on this stuff, and they're both supposed to be 95% accurate on recognizing it as a personal, location, or organization, and the agreement rate between them was 34 to 58%. How can you have a 34% agreement rate on something that the two systems that are both 95% accurate? They were both making many mistakes, but they were overfitting to the results of the Connell and various shared tasks they did well in the shared tasks, they just didn't agree with each other on the problem in general.
Yes. Right. So the second main benefit of these competitions is that it can form a research community, right? So I place like a track, which is what these little tasks within TREC are called, or they're called TREC tracks. A track within TREC can provide the critical mass along with this infrastructure, but a critical mass of researchers to actually start up or at least bolster an existing research area. And the risk here is you want to make sure that if you're going to have an entire research community now focused on this task, which you are defining, that you better have a good definition of this task, right? Because if you do a poor task abstraction, you're going to waste a lot of resources, researcher time, probably some money, on something which is not in the end going to be at all useful. And so what's a good evaluation task? That's still somewhat of an art of defining what a good evaluation task is, because it has to be an abstraction of the real world task so that you can have enough control over the variables. But it also has to be close enough to a real world task so that it can inform that task, right? There's no sense in defining something that is nice and crisp and clear if it doesn't inform what it is that you want to do. And as a matter of sociological interest, you want to make sure that the task is not too hard, right? Because if it's too hard and nobody can do it, you don't learn anything. All you can learn is that it's too hard and nobody can do it. But you also really lose people's interest if you keep telling them that they failed miserably. You also don't want it to be too easy for the same reason of, people might be happier then, but you still don't learn anything because everybody can do it. So there's this balancing act of making the task adequately difficult. And if you're creating your own measures for this task, that's another whole can of worms. But you would like these measures to be diagnostic if possible, right? Which actually says not just this run is better, this system is better than that system, but why, right? Is there actionable information there for the researcher that they say, this failed because you didn't do synonyms correctly or whatever the reason. So it can form a research community, but it's going to form a research community on the task you define, and so that task had better be reasonable. Closely related to forming the research community is then defining this research methodology, right? You want to define the measures which will drive what people do, right? It is definitely the case that what you reward, you get, right? So you want to make sure your measures are going to reflect what it is, the behavior that you would like these systems to do. But then there are some I think of them as administrative if you want to, but they matter. And this is things like, at least in information retrieval, these measures basically have to be interpolated because you only have, what I'm thinking here is precision and recall. I don't really want to get into all that, but you have standard definition, standard points in which you would like to take another measure, but those measures don't occur, those values don't occur naturally, and so you have to interpolate between the ones that that you are taking. And the way that you interpolate, the particular manner in which you interpolate changes the scores, and it can change. It doesn't tend to change the way the systems rank, but if you do them differently, that does matter, right? Because then they're incomparable. And that was the whole, before TREC started, that was one of the main problems in the field, was that everybody's results were incomparable to every other research group's results, because even if they were using the measures that they called the same thing, they weren't actually implemented the same way. And so they were incomparable to one another. And that's what we're trying to get away from. So we defined a standard way of interpolating these things, of calculating the measures. I didn't really have a risk associated with this other than what I called here, what did I call here? Data set abuse. Yeah. There are things which look reasonable to somebody who is not really familiar with the field, which are not reasonable in actuality, right? So one of the things that I have learned as a provider of data sets, that if you make this data available, people will use it, but they won't necessarily use it the way that you intended them to use it. And it would be good if you could be somewhat proactive about that, and at least try and stop the big.
I'm going down to put the
of it.
sheets in the dryer.
So one of the things that which people using TREC collections who are not well versed in what they mean equate relevance with popularity, and that's explicitly not true. Right? Things can be relevant even if they are not retrieved by many retrieval systems, and things that are retrieved by many retrieval systems may not be relevant. Right, but there are all sorts of people out there who are trying to use popularity as relevance, and it doesn't work. All right, the other thing that these coopetitions and provide the capability of is technology transfer. And this is not just between research and commercial, but it's among the different research groups and things. There's this picture here of Watson because IBM did use the TREC question answering track as their initial foray into creating what became Watson. The risk here of this technology trend, it's definitely the case, at least certainly within early TRECs, that anything that was successful in 1 year was implemented by the vast majority of other groups in the following year. And that can be very rewarding, right? It's nice to see progress being made, and it's nice to see people paying attention. But you also want to make sure that you aren't converging too quickly, right? So you got that this is the standard. This is a standard objection to standards, right? That you don't want to create a standard too soon, because you don't want to eliminate people thinking about other methods. How does TREC avoid that? I think basically our main way of doing that is we change up the tasks enough that you have to sort of keep on your toes about what might be the next best thing to be doing here. Okay. The final thing that TREC or that these coopetitions do is build this infrastructure, and it more amortizes the costs of this infrastructure over a lot of users, right? So that's good. It can cost individual research groups some to participate, though, One is it does take researcher time. In order to have a community evaluation, there has to be some level of bookkeeping that goes on, right? And that takes some of the researcher time, to format things in the correct way that they need to be submitted or whatever. As an evaluator, you try to make those things as painless as possible, but it's going to be there. Since the test collections are made publicly available, one individual research group could avoid the cost of participating and still benefit from the construction, because the test set is constructed and they can use it. That doesn't work in the limit, because if everybody does that, then it doesn't get constructed, right? Because we need this participation from these groups in order to build these systems, to build these collections. And so there is a level at which, if you don't have sufficient participation from the community at large, the test sets that you build are not good because they're not representative enough of the real problem. Okay, that's the end of this part of my talk. Well, here's sort of a summary. I've said all this, just there's the summary of it. So what I was going to do now, or what I have available now, is 3 different examples of the way that we have particular tracks or pieces of TREC, which I consider to be, really good examples of what we've done. I don't know how long you want to go though, and so I can stop here. Also, this is a fine stopping place. Continue. Okay. Okay. So the first example I want to do here, this was not officially actually part of TREC per se. It's called TREC COVID. So in March of 2020, the OSTP, which is the Office of Science and Technology Policy at the White House, made a deal with the Allen AI Institute to gather the literature about COVID. And then they issued a call to all the federal agencies saying, okay, what are we going to do with this data? Right? And so one of the things that we're going to do with this data, we propose to create a test collection based on the documents that the Allen Institute was collecting. But why would we need that, right? I mean, so the simple answer there is OSTP put out this call, and we're a federal agency, and so it was good brownie points. But the real answer is the information seeking behavior in a pandemic is actually very different from any of the test collections that we had already created. And we wanted to create a test collection to capture that behavior while it was happening. Okay. And the differences within this information seeking behavior in the pandemic were through these 3 main things. One is the topics that were of interest changed very quickly, right? So as people understood more or less about what was going on, right, the things that they were interested in knowing about changed. The literature just exploded, right? So in February of 2020, you had almost no mentions of COVID, right? And by September, you were drowning, right? And another main thing, which was not necessarily unique to a pandemic, but was certainly made worse by the pandemic, was the use of what's called gray literature, right? So this is non-peer reviewed, but people wanted to know it, right? You wanted to search it, but it wasn't peer reviewed. And because it was not peer reviewed, it changed sometimes daily, right? I mean, it was all over the place. And as a collection builder, the other part that made me mad, as in insane, was that as literature became gray literature into the actual literature, right? It would change titles, it would change references, the citations, all of that would change. I'm used to having test collections where the document ID was the document ID. That was not true anymore. So there's all these things about that was happening, which is why we wanted to build a new collection. So TREC COVID started in April of 2022, ended in September. It was 2020, ended in September. And within that time, during a pandemic, we got people to participate, right? Run their systems, send us NIST the results. We got assessors. The assessors needed to be biomedical experts, right? So some of the assessors, the human assessors, were indexers at the National Library of Medicine. Some of them were other biomedical students in various other places around the country that we had access to because of our previous work with medical folks during other TREC tracks. We did 5 rounds in that time frame, and we eventually built a collection that at the end ended up with about 70,000 judgments on the 50 topics, which is our sort of TREC standard number of topics to have, and about 200,000 articles. The 200,000 articles is very small for a TREC collection in general, but that was the literature of the time, time stamped of that end period. All of that information is archived on a TREC website at NIST. It includes the sorts of the topics, and the judgments are all there, so the collections themselves are there, but it also includes the score reports that systems got back, some analysis of the collection quality, which if I do say myself, it's a really good collection. And why is it a really good collection? Partly because it's small, and so the systems did really good. They were very effective in retrieving things. Also, they were very effective in retrieving things because of the close number of rounds and the way the judgments were done in the rounds. They had training data, right? Early rounds produced training data for subsequent rounds, and that makes the retrieval systems better. So they really were actually pretty effective. Since the retrieval systems are effective, and we look at the top ranks of what the retrieval system produced, we found most of the relevant documents, I would claim. We did some analysis of that, and I'm pretty confident that we found a good majority of the relevant documents. Yeah.
I'm not sure what you're trying to achieve here. Now, I did a study for the Canadian government on the efficacy of oncology treatments. And we went to all the hospitals, and we did analysis. We came back with the recommended most effective treatments. But so we came back with the positive results. What you're doing here, it sounds like what you're doing is you're coming back and saying, yes, COVID is bad, without providing any suggestions for the government or medical to go with this. Am I wrong?
Yeah, no, so the topics, the queries that were used in the test collections were a wide variety of different things. Including some consumer-based, so the things that you would get typed into WebMD or at the NLM. Also some highly technical science, science researcher type, what's the relationship between X, Y, and Z. And the aim here was, we did, for those queries that were part of the test collection, we now have a human curated set of documents that says, here's the literature you should start with for those particular questions. But that wasn't the main goal. The main goal was to create a test collection so that future retrieval systems in the next pandemic would have a better idea of how their systems should be searching. Okay. A second example, and then I'll stop after this example. We had a question answering track, which I alluded to already once with Watson. It ran for a long time. That notice had started in 1999. that's a lifetime ago at this point, right? Because what is a question answering system? A question answering system is a system that returns an answer rather than a set of documents that hopefully contain the answers. What is it that all, the Siri in your pockets or the Cortana in your, what we're trying to do? They're question answering systems. What is all the buzz about ChatGPT? They're question answering, right? This was in 1999. We started this. It was started actually as a program, not in DARPA. This was IARPA program called Acquaint. I bring that up because if it's a STAR ARPA program, that program is funding researchers to do this work, right? Which largely means there's money in it, so there's participants in it, right? And there was a lot of interest at the time. So it had lots of participants. We did a lot of work in looking at this area of what would it take to be a question answering system rather than a retrieval system. The track started with simple questions, what I call factoid questions. Who invented the paperclip? What's the capital of Alabama? I don't think that was a real one. Who invented the paperclip was an actual TREC question. I don't think what the capital of Alabama was. We gradually got into harder and harder sets of things, harder for the systems, but also harder for the evaluators, right? So we started with lists. Lists are basically just multiple factoid questions, factoid questions that have multiple answers, essentially. But then also series of questions, and that's what's shown here, right? That's actually getting closer to an actual conversation, right? Because it would be better for the system to be able to remember what the answer was for earlier questions in order to inform later questions. And also definition questions, what we call definition questions. So these are the who is or the what is. And those questions are really hard. They're hard to answer and they're hard to evaluate because you have to know what not to say, right? If you go up to a person and say, who is Winston Churchill? They're not going to start listing all these things that Winston Churchill is not, right? I mean, while true, it's not informative. And so this idea of what to include in an answer for these definition questions was really challenging. And it's still challenging, frankly. They're better at it now. Systems are better at it now, but than they were. There were some challenges in this, in all of the years of the QA TREC. One is we were used to building retrieval test collections where once we had these human judgments, they could be reused by anybody and they would be the right answer. It's not true with question answering anymore, because question answering comes back with a string and we can mark those strings as right or wrong, but the next person's string, it's essentially as challenging to know whether that string is the same as that string as it is to answer the original question. And so these are not reusable test collections in that sense. And that means we spend lots of time and effort for much less return because many fewer people can actually use them. There was also, remember I said that it was funded. It was an IARPA program. And that ended up being that there was a small number of really good systems and a larger number of not so good systems, and trying to build tests which were encompassing that range was difficult. And actually we failed at the end to really do that. We sort of just focused on the IARPA funded programs because we were trying to, it was an IARPA evaluation. And there's also was challenging in trying to do this balancing act between control of variables and realism. And some of the things that we learned in TREC, or we did in TREC, and I will claim learned, have subsequently not been learned. Right? I mean, so there are other people have created other question answering test sets these days, and I would claim that the TREC ones are much better than the subsequent ones. mostly for this reason of balancing realism and control. So let me end actually with this, which is apropos to these question answering test sets. Any test set, it doesn't have to be a test collection in IR, sort of any test set is a measurement device. And that measurement device is going to give you an instance of a measurement. And it's going to give you this measurement with some degree of error, because some of these things can't be measured finely, and there's always going to be some inherent noise in your measurement. And so you have to make sure that you have some credible relationship between what the test set actually is and what you're claiming that it is. And you have to recognize that there is this noise. And so my public service message for the day is don't interpret measurement error to be superhuman performance. Okay, systems are not better than humans at many of these things, even if the test sets show they are. The test sets show they are is actually the measurement error that people are ignoring. And I'll stop there.